Your model is only as good as the data you feed it. Feature engineering is the process of transforming raw, messy data into a form a model can actually learn from. And it's often the single highest leverage step in any machine learning project. Raw data doesn't arrive ready to use. Dates come as strings. Categories come as text. One column holds values in the tens and another in the hundreds of thousands. Some cells are simply missing. Models need numbers, comparable scales, and no nulls. Feature engineering is the bridge between what you have and what the model needs. The first thing to handle is missing values. Dropping rows works when under 5% of data is missing. But beyond that, you start losing too much signal. For numerical columns, use mean or median imputation. Median when the distribution is skewed because the mean gets pulled toward extreme values. For categorical columns, use mode, if the fact that a value is missing is itself informative. For example, a missing income field might indicate unemployment. Add a binary indicator column alongside the imputed value. And critically, always fit your imputer inside each cross-validation fold, never on the full dataset first. Categorical features must be converted to numbers. Label encoding assigns an integer to each category and works only when there is a natural order. Low, medium, high. For unordered categories like colors or cities, use one-hot encoding, which creates one binary column per category. For features with hundreds of unique values, target encoding, replacing each category with the mean target value. Works far better than one-hot. Feature scaling is essential for any model that measures distances or uses gradient descent. Without it, a feature with values in the tens of thousands will completely dominate one with values between 0 and 1. Min-max normalization squashes everything into the 0 to 1 range. Z-Score Standardization shifts the distribution to mean 0 and standard deviation 1. More robust when outliers are present. Tree-based models like decision trees and random forests are the only exceptions. They never need scaling. Beyond cleaning, you can create entirely new features. Extract year, month, and day of week from dates to capture seasonality. Divide debt by income to get a debt ratio that's more predictive than either column alone. Apply a log transform to compress right-skewed distributions income data almost always benefits from this. Bin continuous values into groups when the relationship with the target is nonlinear. These domain-driven features often outperform any raw column in the dataset. Feature selection removes what hurts. Start with correlation analysis and tree-based feature importance to eliminate clearly irrelevant columns. Use lasso regularization or recursive feature elimination to trim further. Fewer, better features almost always beat many noisy ones, and they make your model faster and more generalizable. The most important thing that ties all of this together is the Sklearn pipeline. It chains your imputer, scaler, encoder, and model into one object and ensures that every transformation is fitted only on the training fold, never on validation data. This is the only reliable way to prevent data leakage. Thanks for watching. If this helped, like, comment, and subscribe.